Hello, my name's Emma and I'm the Education Officer for Westmill Sustainable Energy Trust. Thank you for choosing to use our video presentation. This first slide is really for anybody who's presenting this video. I just wanted to let you know that you can find associated documents on our website at this link. These include a lesson plan, a delivery guide. Now that will enable you to give children a little bit more detail and background and answer further questions. There's also some further points for discussion there as well. Worksheets, these can be printed off. There's a black and white version as well as a colour version, and there's also one that's fillable, so you can download it and save it and then have it filled on a laptop or tablet. And there's worksheet answers as well. On most slides that you will see that there are questions highlighted in orange. There are also some other questions that I'll ask throughout the presentation. Do please feel free to pause the presentation after any question. I'll try and leave a short gap so that children who are watching the presentation on their own have a chance to think about their answers. However, please pause it at any time that you feel it will be useful for children to deliberate or discuss their answers. There are also tasks throughout the presentation, and this is another opportunity to pause it and then give them an opportunity to fill in the worksheets that are associated with the presentation. But do please feel free to pause it at any time. So let's get started. Welcome to this fifth lesson looking at solar energy. We've already found out a bit about renewable energy sources, and last lesson we looked at wind energy. In this lesson, we're going to look at why the sun is so important to life on Earth, and how its power can be harnessed and then transformed into electrical energy. And just like we did with wind power, we're going to take a look at how this solar energy can make a huge difference to our lives. So let's get started. Just imagine waking up one morning to find that the sun just hasn't risen. I'm not talking about a winter morning. I'm talking about a morning when you expect it to be there in the sky. I'm going to ask you to make a list of 5 things that you would miss most about the sun if it wasn't there. Well, I'm sure you've come up with lots of things. You might just have said something as simple as sunrises and sunsets. They're beautiful, and it's wonderful if we get a chance to stop and enjoy them. But how about the fact that we need light to live and work by? Or the changing of the seasons. Now we have seasons because the Earth is tilted slightly on its axis, so as it orbits the sun, some areas receive more sunlight at different times of year. So for us in the northern hemisphere, when the North Pole is tilted more towards the sun, it's summer, and when the South Pole is, then we have winter. There are other important things, like the fact that plants rely on the sun to grow. Imagine a world without sun is a world without plants, and in fact life really. And warmth. Without the sun the temperature would drop. In fact, life on Earth could only survive down to a certain temperature. And finally, we would also not have the benefit of our moon, because the moon reflects light from the sun, and that's how we get moonlight. Did you know the sun is actually a star? And it's our closest star. It's at the centre of our solar system. Now the word solar comes from the Greek word for sun, which is sol. It's made up of a hot whirling mix of gases, and so it's amazing really that it's almost perfectly spherical. The sun's energy is incredibly powerful, but what types of energy does the sun provide? Well, it provides us with heat energy and light energy. But if you think about the movement of the gases on the sun, that's also kinetic energy. We can benefit enormously from exposure to the sun, but whilst we need sunlight to help us make vitamin D amongst other things, the sun's energy is powerful and overexposure can be harmful. There are plenty of products that we use to help protect ourselves, everything from sunglasses to sunscreens. However, saying that, simply limiting exposure and covering up and keeping in the shade when the sun is very strong are sensible precautions to take. So we know that we receive the sun's energy in the form of heat and light energy. And the sun is around about 150 million kilometres away, so it's amazing to think really that it only takes around 8 minutes to travel to Earth. Thankfully, during this time it loses some of its power, otherwise the Earth would just be a burning mass. The Earth is actually the third planet from the Sun, and its path around the Sun is called its orbit. It takes the Earth 1 year to completely orbit the Sun. The Sun also turns and takes 25 days to complete one full rotation. So I wonder if you know, is it the rotation of the Earth or the rotation of the Sun that means that we have day and night? It's the rotation of the Earth, and that takes 24 hours. So we can tell the difference between day and night, but how can the sun be used to actually tell the time? So, as the Earth turns, the sun seems to move across the sky, and the shadows cast by objects and people will change in length and direction. So these shadows can be used to chart the passage of time, and then sundials were designed to do this by dividing the day into segments or hours. Sundials have been used for hundreds of years. In fact, the use of sundials has actually been traced back thousands of years, and some have even been found in ancient Egyptian ruins. The sun is so vital to life on Earth that it's actually been worshipped throughout history by many different cultures. It's easy to focus on light energy from the sun, but its heat energy is equally as vital. Without the sun, within a week the temperature would plunge to well below 0 degrees Celsius, and within a month the oceans would start to freeze over. So, we know that the Earth's revolutions give us day and night, and its orbit around the sun gives us the seasons. And it also regulates our climate, and it ensures that the Earth is a habitable place. But in what other ways do we benefit from the sun's energy? Well, we mentioned it at the very beginning. As well as giving us light and warmth, which are both vital, the sun enables the growth of plants, without which we just couldn't survive. I wonder if we start to see the sun differently when we realise it's something we just couldn't live without.
Pop quiz. What's the closest star to Earth? It's called Sol. Never heard of it, you say? Sure you have. Sol is the sun. Ancient Romans, who once worshipped the sun, called it Sol, and it's become the kind of official scientific name for the sun. It's where the term solar system comes from. Sol, or the sun, is the star at the center of our 8-planet solar system that provides us with energy. Without the sun, Earth would be a dark, frozen world with no life. But how does the sun's energy get to us? Well, first, let's talk about what the sun is. It's a 5 billion-year-old big ball of super hot gas. The hottest part of the sun is its core, or center, which is about 15 million degrees Celsius. Whoa. Its surface is not quite as hot, but it's still almost 5,600 degrees Celsius, which is pretty toasty if you ask me. And as for its size, the sun is so huge, you can line up over 100 Earths along the face of it, and more than 1 million Earths could fit inside it. But the sun's size isn't what makes it seem so big and bright to us on Earth. It's because it's so close to us that it seems way, 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 way bigger and brighter than other stars. So, you know that the sun is hot and bright, and that heat and light are both kinds of energy that we get from the sun. Let's take a look at a model to see how the sun's energy gets from good old Sol to our planet. Here's the sun. Energy is created in its super hot 15 million degree core. That energy then travels outward from the core to the surface of the sun. But this journey from the center of the sun to its surface can take over 100,000 years to complete. But once the energy deep inside the sun finally gets to the surface, it travels as light and heat all the way to Earth. In fact, it only takes about 8 minutes for light to travel approximately 150 million kilometers through space to Earth over here. That's not such a long time. So to sum up, energy is created in the sun's core. It travels very slowly to the sun's surface before it takes a super speedy trip to Earth in the form of light and heat. And you and I can see and feel that energy as sunlight. Without the heat and light we get from the sun, Earth would be just a frozen ball floating around in space, which would be a total bummer. So, thanks, Soul. You're a real star.
So let's see what you've learned so far and have a go at task 1, Bring Me Sunshine. If you'd like to press pause to allow time to complete task 1 on the worksheet, do so now. You can then press play to continue watching the presentation. So we asked you to use the words in the list below to fill in the gaps in the following sentences. Let's see how you got on. The sun is our closest star. It is at the centre of our solar system. The word solar comes from the Greek word for sun, sol. Some of the sun's energy radiates as far as the Earth. We receive this in the form of heat and light energy. One revolution of the Earth takes 24 hours, giving us day and night. As the Earth turns, the sun seems to move across the sky, and shadows cast by objects and people will change in length and direction. These shadows can be used to chart the passage of time. Sundials were designed to make this easier to read by dividing the day into segments or hours. Well done. So, just like we need to be able to measure wind speed and wind direction, we also need to be able to measure solar radiation. Scientists measure solar radiation in order to study climate variations and change. They also use these measurements to help forecast the weather. I wonder if you know what a meteorologist does. A meteorologist is a scientist who studies the atmosphere, including environmental effects and changes, and uses analysis and observation to understand and explain or forecast changes in the atmosphere and its effects on the Earth's weather. We use different types of meters to take measurements. A solar radiometer is a device used to measure the intensity of sunlight on a surface, whereas pyranometers measure all the radiation from the sun. We've talked about some of the reasons scientists and meteorologists need to take measurements, but why might we need to measure light or heat levels? A reason might be for horticultural or agricultural applications, so that's gardening or farming, to help us understand how plants might grow, or in order to make weather predictions and get UV warnings, so that we can cover up in response, or even to enable those working in solar energy to calculate how much electricity a solar energy installation will produce. So now we come to solar panels. And these are devices that are designed specifically to collect energy from the sun and then to transform it into electrical energy or electricity. We often see them mounted on the roofs of houses or on offices or buildings. However, you'll also be familiar with large solar farms or arrays. So the first silicon-based photovoltaic or PV cell was created way back in 1954. That cell could power small electrical appliances, but wasn't anywhere near as efficient as those that we now use. Whilst they weren't commonly used in the home at that time, they were used by NASA to power satellites. So by the time the 1970s came, advancements in the technology had brought down the cost, and since then they've become increasingly viable for applications ranging from domestic panels on roofs to solar farms, like I mentioned, or personal devices and technology, and increasingly transport like cars and even aircraft. So do solar panels need direct sunlight to work efficiently? Advancements in the technology mean that solar panels don't need direct sunlight to work efficiently. They generate energy from daylight rather than direct sunlight, which means they will work on cloudy days too. As we've mentioned in earlier lessons, we use AC or alternating current in our homes. Now solar panels generate DC or direct current, and so an inverter is needed to convert this to AC. In domestic systems, so those in homes, inverters are often a sealed unit located either in an attic or a garage, or a unit on an external wall. If we have solar panels on our homes, how do you think we can make best use of solar energy 24 hours a day? Although solar panels don't work at night, if a battery is installed, this enables solar energy to be stored and used during the night as well. Battery technology is also developing, and that enables this to be done more efficiently. Any electricity that isn't used by a homeowner can be fed back into the national grid. Solar panels are made up of many layers of materials, each of which has a specific function. So let's take a look at these. Firstly, we have a layer of blackout material, followed by what's called a UV enhancement film. Next is a layer of glass, which goes on to an adhesive seal, and then a full adhesive sheet, which is laid on top of a copper foil contact, and you can see that there, it's an H shape. Underneath that foil contact is adhesive of the same shape. That then joins it to the silicon PV cell. Under that cell is another sheet of adhesive, a backing material, and a high bond adhesive. That sits onto what's called the core plate. And running through this up into the PV cell, we have a wire. Now, we'll talk about the function of the solar panel in a bit. But what do you think the function of the blackout material, that first layer, might be? Well, this blackout material is glass that's coated with an anti-reflective material to maximise light absorption. It also reduces glare, which is important. So we saw in the last slide that right at the centre of these layers was a PV cell, or photovoltaic cell. Now each PV cell is made from two silicon layers and a metal or silver contact sandwiched in between the glass. So first, photons from the sun hit the panel. Then the top silicon layer absorbs the photons, and this excites the electrons in the cell. In other words, the electrons start moving around. Then the metal contacts within the panel allow these electrons to flow through the layers, creating DC or direct current. When you look at certain types of solar panel closely, you can see flecks. What do you think causes these flecks that you can see underneath the surface of the panel? The flecks are actually the crystals of silicon.
Question: what's the most abundant energy source in our solar system? Here's a hint. It's 1 million times bigger than the Earth, And without it, our planet would be a dark, cold rock floating in space. You guessed it, the incredible, brilliant sun. The Earth gets more energy from this ball of fire and gas in one day than the whole world's population uses in an entire year. Every living thing depends on the sun for its existence, from tiny microbes deep in the ocean to plants, animals, and people. Humans have been tinkering with solar energy since the dawn of time. Ancient civilizations used glass and mirrors to light fires, but it wasn't until the 1950s that technology was developed to convert the sun's energy into electricity using photovoltaic cells. Today, solar technology is more efficient and less expensive, and is used all around the globe to create electricity, heat water, cook food, and even power vehicles. So how do solar panels usually work? When the sun hits a solar panel, material inside, usually silicon, absorbs the energy. This causes the electrons in its atoms to get very excited and start dancing around. The atoms then get hot and shed the electrons, which travel out of the panel through copper wiring, and zap! We have electricity. A control device, called an inverter, changes this electricity from direct current to the alternating current we use. The electricity then passes from breaker boxes to outlets and into electrical items, like your computer and lights. Whatever you don't use can go back into the grid to be used by someone else. So there you have it, the amazing power of the sun. Some people see a future where most of our energy can come from this pollution-free and renewable resource. And that's a sunny outlook that will make the whole world smile.
That video was a great recap. So let's have a go now at task 2 and look at a solar installation. Once again, if you'd like to, you can press pause to allow time to complete the task, and then press play to continue. We asked you to examine the image of the solar installation on the house below and then see if you could answer the following questions. So let's go through them. Do solar panels require direct sunlight to produce energy? No, they can generate energy from daylight. What direction should solar panels be facing in the UK? South. How is direct current from the panels converted into alternating current that can be used in the house? By using an inverter. Circle the point on the image where this is happening, so we're looking for the inverter. Think about what we talked about earlier about where this might be situated. There we go, and it's in a box on the external wall of the house, but it could also be in an attic or garage. What happens to any excess energy produced that isn't used by the household? It's fed back into the national grid. And then finally, circle the point on the image where this is happening, so where it's being fed back into the national grid. There we go, where wires are going from the house onto a pylon. Hope you did well with that. Well done. We've talked about photovoltaic technology going right back to the 1950s. And actually, solar-powered calculators were first available in the 70s. I had one when I was at school in the 1980s. The technology has come a long way since then, but still, many relatively low-cost, smaller products incorporate solar technology. You might be familiar with things like calculators that we've spoken about, or even solar chargers, garden lighting, fairy lights, radios. Nowadays, though, we can also create vast solar arrays that cover many acres. What do you think the term solar array means? Think back to earlier lessons, we've talked about this one before. Remember, this is the term used for a group or rows of multiple solar panels. Just like with wind, there are myths surrounding solar power, but people also have very genuine concerns. Remember, we said it can take a while for people to get used to new technologies. Some people say that they're dangerous and can cause glare, or that solar panels can't be recycled. They also claim that they require a lot of maintenance, and that they don't work when it's cold or cloudy. I wonder if you have any worries about solar panels or solar farms. Once again, if you do, it's always really important to discuss this and also to look to find out the truth behind any things that you hear online or on the radio or on television. We should always look for fact-based evidence. So let's talk through some of these concerns that come up. One of the common ones is that they cause a dangerous glare. But because solar panels are designed to absorb light and usually incorporate blackout materials, they reflect relatively little light, so actually less than domestic windows in our house, or even actually the amount of light reflected by snow. Remember, they need to be absorbing the light to function. People also argue that solar panels can't be recycled. Well, to start with, they last around about 25 years. And actually also, if solar panels are removed to be replaced or updated, they're often refurbished and reused by other businesses. They can also be dismantled, so taken apart and split into their component parts. We've already seen the layers, so these consist of materials like glass, plastic, aluminium, silicon and other materials, and these can all be recycled. In fact, as solar panels have grown in popularity, so have businesses specialising in recycling their parts. Some people worry that they require a lot of maintenance. But actually, solar panels are constructed to withstand harsh weather, and they actually require very little maintenance. However, the panels do need to be cleaned and checked occasionally to ensure there's nothing blocking them from efficiency. So that might be to remove things like leaves or even bird poo. Some people even still claim that they don't work when it's cold or cloudy. Now, we've already spoken about this. These days, solar panels don't need direct sunlight but can operate just in daylight, so even when it is cloudy. They can also operate in low temperatures. In fact, solar panels are more efficient on a sunny winter's day than in a hotter one. It might be worth looking into this a little bit further. How do you think fields with solar panels in them can be used to increase biodiversity? Remember, biodiversity is the range and amount of plant life and animal life. Well, some fields used for solar panels, for example on farms, are actually still grazed by animals. However, they can also be left to meadow, like ours at Westmill, and these meadows attract insects and butterflies and bird life and lots of small animals as well as new plants. So solar panels can live very much in harmony with nature. hope you enjoyed that time-lapse video of the construction process of another solar park in Oxfordshire. Sadly, we don't have one showing ours, but it's a similar process. Our site is also surrounded by a field hedge, which means it can't be seen from the road. And whilst access to the actual park itself and the solar panels is restricted in our case, we do have public footpaths going very nearby, so it's still easy to come and see ours. Just like wind, solar is growing fast, and the technology is also improving, so that means that the costs are falling. As I mentioned before, battery technology is also improving, which means that we can store more energy. Another great plus point for solar is it reduces our reliance on what we call wired electrical grid networks. So that means if we're not on a grid network, we haven't got electricity through a grid, we can install panels where we need that electricity. Panels themselves can also be installed on products, so they can be used wirelessly. Can you name some countries you think could benefit particularly well from solar power? Well, it could be countries like those on the equator that have more consistent numbers of daylight hours throughout the year, or countries that have more sunshine and higher radiation levels, but maybe less access to things like wind power. Also, large countries which are geographically hard to reach, or where it's logistically difficult to install a grid network. Interestingly, it's been suggested that if we could cover roughly 1% of the Sahara Desert with photovoltaic solar panels, then we would be able to generate all of the world's electricity requirements, as the sun shines brighter in the Sahara, so the radiation levels are higher. So why don't you think this strategy has been implemented yet? Well, there are several difficulties with doing something like this. For starters, sand is not an easy surface to build on. It gets very hot, and that can actually reduce the efficiency of panels. And things like sandstorms mean that panels would become obscured very easily and need much more cleaning and maintenance. Another issue is that the Sahara is relatively low in terms of inhabitation, so you'd need to transmit that electricity, and that could be an incredibly long way to get it to where the demand is, and this could be a real problem. So, whilst it sounds like a great idea, we have to think these things through, and the obvious is not always the answer. The story of a business called Little Sun is an excellent example of the difference that solar innovation can make to individuals and communities that don't have easy access to electricity from the grid. The designers and engineers at Little Sun have created a range of small portable solar lights and chargers. How do you think these portable solar lights could improve the lives of school children, for example? Well, they could improve safety, giving children personal lights to help them on the long walks to and from school that they often had to do in the dark. They also enable them to do homework in the light without having to strain their eyes. Their products are now available all over the world, and for every Little Sun product purchased, the same one is made available to someone without access to electricity. So, using our solar array at Westmill and also the company Little Sun as your inspiration, let's have a go at Task 3, the Solar Challenge. Your challenge is to design a solar streetlight, and this could be used on pathways between villages or towns to light the way, making it safer for children to walk to school. Now this could be for anywhere in the world. You could even choose to do it for your own journey to school. We're asking you to present your ideas in the form of a drawing with notes, and there's space on the worksheet for you to do this. If you use notes, or what we call annotations, these can help you explain your ideas. It could be anything from the colours and materials you want to use to the features of the light. Then, if you can, present your ideas to your class or family. The design must use energy efficiently, so have a think about that and make sure that it fits nicely into its planned location. Here's that word aesthetics again. Remember, it means how something looks. You need to think about the aesthetics of your light design. Press pause now to allow yourself some time to complete this task, and then when you're ready, press play to continue. I bet you've come up with some really good ideas. Now unfortunately I can't see them, so let's go through the challenge together by looking at this nice example called Solar Tree, which was designed by an architectural company. While we're going through this, if you have any more ideas, just note them down on your paper. There are several areas that you might have considered, so let's look at how they've been considered here. The first one is form or shape. Well, the clue's in the name. The form of this design has been inspired by a tree, or at least organic shapes like plants. We've got a kind of central stem that then divides and spreads out into a sort of canopy design. If you look at the base, you might also say the form is a little like a flower with stamens coming out of it. Either way, I would say that the form of this design is organic. Next, let's look at the function. So here we have the solar panels. Now they're on flat pieces at the top of the design, allowing them to be facing right up and getting as much of the sunlight or the daylight as they possibly can. These will charge during the day, and then there's a timer system, which means that as it gets dark, lights below these little platforms will gently come on, so the light is then projected down underneath the tree system. Now the stems or branches might also be hollow, so theoretically, and you might have come up with something like this in your design, wires could pass down them, and these could be linked to something like charging sockets at the bottom. You can also see that part of the function of this design is for the base, which is wider than the stem and so holds the whole construction stable, is also designed as a circular bench to allow people to sit, and because there's light coming down they can then read or work or chat or use devices. Next we have the aesthetics. This is how it looks. Now we've said the form is an organic one, and for me, I like organic shapes, so I find this aesthetically pleasing. I like the way it looks. That might not be everybody's opinion, but they've tried to make it more aesthetically pleasing by blending it into the surrounding environment by making the stems or the branches a green colour which fades at the top. Because it looks like a tree, it blends into the natural environment. Many people will find this much more attractive than the standard single pole with a light at the top, where not much thought has gone into the aesthetics. Finally, you might have gone as far as to consider the construction and the materials. So, what sort of things are you going to use? What materials are you going to use to make your design? With a design like this, they're probably going to choose something like tubular steel, which is strong but not too heavy because it's tubular, it's hollow. That also allows, as we mentioned before, cables to be passed down those tubes if necessary. Tubular steel can also be painted so that it's weather resistant. and can easily be joined by welding or using mechanisms like bolts. When we look at the structure of the seating below, we can see that it's made from multiple sections, and these could well be made from press-formed or bent steel sheet, which is cut to the right shape and then put in a former which gives it the bent shape. These have then been joined to a kind of substructure, something underneath, again probably steel, something which is heavy and strong. And you can actually see the fixings at the back at the top and also on the seat. These are probably bolts that fix through onto the substructure. And again, this has been painted to protect it from the weather, but also to mean that when people sit on it, they don't get any rust on their clothes. One consideration with steel seating is that it can get very hot in the sun, so actually if this was in a hot country it might have been made from something else like bent plywood or even some sort of fiberglass or plastic. I hope this task has got you thinking a little bit and maybe even being inspired as to how solar technology can be used in new, exciting and innovative designs.
At Mahindra Solar, we're starting a solar energy revolution. We're lighting up villages, and the villages are using solar lights to achieve much more. Someday, we'll be proud to say that we did our bit in helping millions like Malti realize their dreams.
Well, I hope you found that video as inspiring as I did. I think it really shows the difference things like access to solar energy can make to people's lives. It's exciting too that as this technology grows, so do the opportunities for jobs in that area, and you too could be part of something like this, changing the way that people live and improving their quality of life. So let's see what you've learned during the lesson and what you can remember. Is solar energy renewable or non-renewable energy? Yes, it's renewable energy. The Earth orbits the Sun. How does this affect our calendar year? Well, because the Earth is tilted on its axis, it gives us the seasons. A light meter is used to measure what? It's used to measure the intensity of sunlight. Solar panels are made up of many PV cells, but what does PV stand for? PV stands for photovoltaic. Now I'd be really impressed if you could spell that. Well, it's PHOTOVOLTAIC. Really well done if you did. What is used to convert direct current, DC, from solar panels into alternating current, AC, to be used in homes? We use an inverter. And finally, I know you know this one because we've been over it, what term is used for a group of solar panels grouped together? It's known as a solar array. Really well done for having a go with that, and thank you also for joining me in going through this lesson. I hope you'll join me again in lesson 6, which is about sustainable development and a sustainable future.